UP Baguio is built on a pine-clad hill in the heart of Baguio City. For 50 years now, since its establishment in 1961, UP in Baguio has worked at serving as the lead institution in the delivery of tertiary education in Northern Luzon, sustaining its efforts at modernization, the strengthening of curricular programs, and the active generation of knowledge through research. UP Baguio is also a green campus in the truest sense of the word, with all sectors committed to the preservation and planting of various trees and plants within and around the campus. It is indeed as the UP in the north that UP Baguio has quite proudly evolved into, carving out a niche in Cordillera studies developed over the past decades. The Department of Mathematics and Computer Science, or DMCS, was first established as the Division of Natural Science, then reorganized as the College of Science in 2002, consisting of 3 departments, namely Biology, Physical Sciences, and Mathematics and Computer Science, and 1 Human Kinetics program. It is the mission of the department to adhere to the highest standards of excellence in all aspects of teaching, research, and extension service. This year, the DMC has ranked number 1 unit in UP Baguio according to the UP System-wide assessment called the Internal Academic Assessment and Development System, or IADS. Currently, the DMCS offers 4 academic programs, 2 in the baccalaureate level, namely BS Mathematics and BS Computer Science, and 2 in the graduate level, namely Master of Science in Mathematics and the newly instituted Doctor of Philosophy in Mathematics. The department's extension programs, recognized and endorsed both by the Department of Education and the Commission on Higher Education, span capacity-building activities in mathematics teaching and research that service secondary and tertiary institutions in the North and Central Luzon and other parts of the Philippines. These programs include It is the objective of the department to strengthen its graduate and undergraduate programs, aggressively promote and maintain standards of quality education, and to lead in research capability building and research-generating activities in the mathematical and computing sciences and mathematics education. Together, the department will continue to maintain nationally and internationally recognized expertise in core, as well as emerging areas of mathematics, statistics, and computer science, and make it accessible to the people in the region. UP Baguio is built on a pine-clad hill in the heart of Baguio City. For 50 years now, since its establishment in 1961, UP in Baguio has worked at serving as the lead institution in the delivery of tertiary education in Northern Luzon. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics.
Good morning, everyone. Welcome to the 27th SINSM Mathematics and Computer Science cluster in Track D with the title Tools and Concepts in Computing. We will be starting at exactly 10:05, so please stand by for further announcements. Thank you very much.
Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics.
Okay, sorry, technical difficulties. Again, good morning. Can you now hear me?
Yes po, sir. We can
Okay,
hear po.
so I'm now sharing. Can you share? Can you see the shared screen, which is just a blank page with a watermark SINSM lecture 2022. Okay, so once again, in behalf of the Summer Institute uh, group, I would like to welcome everyone, and I hope I can try to share uh, some knowledge that you can use as a tool for studying disease modeling. Okay, so in this particular talk, this is just again an extension of Summer Institute uh, that I have shared in 2021. It's the same, except that I will try to concentrate more on the use of the tools, in particular GeoGebra. I'm sure that a lot of you are familiar with this. Okay, so it's a simple tool which you can use to visualize disease dynamics. Okay, and it can also be a tool that you can use for teaching, meaning in order for your students to appreciate, okay, modeling of diseases. Okay, and the other tool that you may want to use is Gamma. It's an agent-based modeling. Both softwares or packages are open source, so it can be downloaded and can be installed in any platform. Okay, so when I say in any platform, uh, you can install it in Windows or Linux, or since Mac is under Unix environment, then it also runs on Mac. Okay, so it's just a matter of choosing the appropriate package that will suit your operating system. Okay. So if you will see, uh, this is version 2, meaning still this is modeling using GeoGebra and Gamma. In my previous talk last year, I think I just gave you an overview, and I was expecting that we can have what you call a hands-on. Okay, so I hope that even if you have, or if you have time while I go over the discussion, you can easily download GeoGebra. uh, I would prefer it can be run or it can be installed in an Android, okay, in your tab, okay, or it can be in your laptop. Okay, I would prefer that you download version 5, okay, because version 6 would be requiring an online, or it can be run online. Okay, so uh, just to give you an overview, we will start with what we call an backgrounder, where we need to know the basics first, okay? And from there, we can try to make use of the tool, okay, for us to visualize and understand what we would like to do, okay? So in this particular area, we will be dealing with what you call modeling, in particular infectious or disease dynamics. Okay. So it can be applied or can be visualized using a numerical tool. Okay. And the other one would be trying to simulate using agent-based. Okay. So just to give you a backgrounder of the talk, I hope that hands-on one will be done on your side. If you have your laptop with you, then you can download Gamma while you listen to the introduction. Okay? For the Gamma, I would suggest that Don't download it unless you have a powerful machine that will handle the resources, okay, required by Gamma. Okay, but in your free time, most probably uh, you can try to download it, okay, and play around with the Gamma. Okay? And at the same time, I would suggest that Gamma would require some knowledge on GIS packages. If you have licensed ArcGIS, then it will be of help, or QGIS, which is an open source. So I use QGIS this uh, uh, in this approach just to make the shape files or download the shape files, because I would like to get hold of shape files, in particular the setting in Baguio. Okay, and for an introduction, again, maybe we would be asking ourselves, why do we uh, build mathematical models? Okay, so maybe you have experience where your students would ask you, uh, why do we have to learn math and never going to use any of it? Okay, so I usually encounter this kind of question for some non-math majors. Okay, and most probably some of you who are into math have asked this early on during your maybe high school. Okay, or maybe students. I would suggest, or I would assume that students was thinking about the connection, let's say, between the mathematics and their future. Okay, so maybe these students are looking into their future. That's why maybe they will look into or ask this possible question. Okay, or maybe a confession from a student that uh, hates math. Okay, so or maybe would not, I would say that they are not fond of math. Okay, so those are possible questions that you might have encountered. I think for me, I would suggest, or I would say that the purpose is uh, or yeah, the purpose of mathematical modeling is to have students develop uh, mathematics from the problem context, okay, and find or to make sense of the situation and the mathematics behind it. Okay, so I think that's what we can look into. Okay, and then the next one are, what are the modeling methodologies? I hope you've seen this slide already, where uh, they have, or we have different modeling methodologies. We can have a lot of students looking into a statistical based method, okay, or possibly in the computer science department would be looking at it in a machine learning based models. Okay, so I would assume that you have a lot of machine learning based models, especially uh, during pandemic, where we have what you call dashboards. Okay, so these are web-based surveillance networks, okay, or more or less trying to uh, give you updates on the status of the disease. Okay, and in this particular talk, I will just concentrate on the deterministic and possibly an agent based. Okay, so again, I will go back to why do we model real world problems. Okay, and I sure when you consider looking at your students, we can have or we can try to explain it and say that in your everyday life, you have or you are able to encounter what you call the modeling process. Okay, so I think math can be, I would say, pathway to many careers. Okay, so modelers use ideas from math to handle big, messy, real world problems. Okay, so if I were to uh, look at this modeling process, I think, as I have mentioned, every students have encountered it, even though they are not math people. Okay, because maybe just the way how you would solve a particular problem, like uh, the usual way to find or what will you eat for this uh, dinner or lunch. Okay, so I think you're trying to solve uh, a mathematical problem. Okay, so to solve a modeling problem, usually mathematicians make assumptions. Okay, choose an appropriate or an approach. Okay, and then get a solution. Okay, and from the solution, assess the solution, and if it's useful and accurate, then possibly if it's not accurate or it's not useful, then possibly rework and then adjust uh, the model as needed until you come up with an accurate prediction, okay, or enough understanding of the real uh, problem. Okay, so if you look at this, what you call this circle, I would say it's a circle wherein you can start with a real world problem, as I mentioned, where you translate it to its math model. Okay, so you are now within the math world, and when you solve the modeling problem, again you what you call this go through what you call make assumptions, choose an approach, get the solution, which usually you try to solve. Okay, and then from the solution of the model, you get to assess the solution. Okay, and maybe translate and interpret it to the real world problem and assess if it is appropriate or accurate. Okay, then if not, uh, then maybe you can adjust, as I've mentioned, adjust the model, okay, and from the solution to the real world problem, meaning adjust it in such a way that you can translate it back again to the math model. Okay, so that's the usual modeling process. It's what you call this an iterative approach. Okay, so again, even let's say people who are said to be ingenious get to uh, get stuck on the wall, okay, when they're trying to solve problems. Okay, so if you look at this, the process itself involves an iteration, evaluation, and then recording the model, and then maybe trying to communicate with others, meaning you now try to ask input from other people, like maybe decision makers or uh, medical professionals, okay, and maybe uh, other social scientists, in order for you to come up with a real world problem and then simplify it again. Okay, so I would say that uh, success is unlikely. So if you are given a real world problem, then it's not as easy as the solution is easily determined. Okay. So now the other question is, why do we model diseases? Okay. So again, modeling diseases, as we can see if we look at what do you call this, the Philippine setting. So this is data which recorded it or burden of disease by cause in the Philippines as of 2019. Okay, so if you look at this one, I think you will have three main groups. Okay, so when we think of let's say diseases, we usually consider the human. What is interesting to take note of is the global burden and how to quantify it. Okay, so we often describe, if you look at the burden of diseases, okay, we often describe the burden as maybe I think it's split into different kinds of conditions. In this particular graph of, or in this particular data, uh, it is grouped into three, maybe diseases of three different conditions: the blue, okay, the blue, the red, and the gray. Okay, so if I look at this graph, in general, the human population is affected or impacted by different kinds of diseases. Okay, non-communicable diseases, and then communicable, maternal, neonatal, and other infectious diseases. Okay, and then injuries. Okay, so it gives you some sort of a distribution of the burden, okay, of the human population. Okay, so if you go back to the previous data, it is now given in terms of what you call the total. So the three main groups. In this case, we can see that it gives you data from 1990 to 2019, and disease burden by cause by injuries would around will have around 10% of the pie. Okay, and if you will notice also that early 1990s, the group communicable, maternal, neonatal, and nutritional diseases uh, ranges from 40 to 90, so that's around 50%, okay, of the pie. And the rest of the pie is from non-communicable diseases. Okay, so if you look at figures 1 and 2, as you can see, we or our world in data recorded around what an increasing percentage in terms of non-communicable diseases. Okay, so uh, in uh, in uh, in infectious diseases, this is only one of the what do you call these conditions, okay, of the as shown here in the graph. Okay, maybe if I were to look at this data, okay, uh, we usually think of it as an issue of, let's say, of, if you look at the uh, part which is infectious diseases, only a part of the red one. Okay, uh, we usually think of it as an issue of the past. So if you look at infectious diseases, okay, but uh, recently with COVID-19, again, it became an important issue of the human health. okay, particularly in certain locations, or in this case, it's uh, in almost all uh, locations, so that's why it becomes global, and certain demographics. Okay, when I say certain demographics, the population and certain groups within it, like age. Okay, so we have seen that age or senior citizen happens to be also an important issue. Okay, that is why when they had to impose vaccination, meaning if you go back to the model later on, when you look at a simple SIR model, okay, uh, what's the purpose of vaccine? Means that it's a way of what you call this, reducing epidemic. Okay, so we will try to see how these things come into action in the simple SIR model that we will try to simulate using GeoGebra. Okay, and other things in what you call this, in that graph. Okay, so if I were to look at this simple data, okay, person one, okay, you will see that in this particular disease, as an illustration, what happens is uh, showing person one goes to a long period of infection, meaning from October to September, so around 1 year. And if you look at person nine, yeah, person one had it onset of illness as early as October, and was uh, infected until he or that person died after a year. Okay, uh, in relation or in comparison with person nine, if you look at person nine here, okay, then you will have a several months, okay, get infected and was able to recover. Oops. Okay. While another person is what? Maybe if you look at person six, okay, gets infected and then and have a shorter time to have the disease and dies here. Okay, while seven compared to person nine took a shorter time for that person to recover. Okay, so we can look at two ways of the burden, okay, on infectious diseases at any point in time. Okay, so important aspect of measuring, okay, or yeah, input aspect of measuring infectious disease burden, maybe before the outbreak. Maybe we can look at prevalence of the outbreak. Okay, so here when you say how do we look at it, maybe in a particular what you call, if you look at a particular time frame, like in this case, okay, you can look at incidence, okay, meaning how many uh, are infected in this particular time, okay, or get to have the disease. Okay, so we can have, and similarly, we can have what we call prevalence. Okay, okay. If you are looking at the graphs, most of them talks about what we call daily. It's the measure the total burden of the disease. Okay, and usually they look at it as years of life lost. It's the sum of years of life lost plus a year lived with disability. Okay, so one 1 year. That is why if you look at children, if they die early, then you have a longer daily, okay, meaning there's a longer uh, total rather lost. Okay. Okay, so again, if you look at daily, the unit daily is I think, yeah, one lost year of healthy life is equal to one daily. So for children, it means that it gives more or a longer or a greater number of life lost, okay, of healthy life. So one lost year of healthy life is one daily. Okay, so let's now look at how do we model diseases. We can look at what particular approach is to perform compartmental modeling. As we have made earlier, in the math world, we first have to uh, agree on assumptions. Okay, so we first have to formulate assumptions about that particular disease that we would like to model. Okay? And in this approach, we will be looking at population under study are divided into compartments. Okay? Diseases that confer immunity have different compartmental structure. Okay? And from diseases with immunity, okay, and possibly uh, what you call this compartments when we have vectors, meaning the disease is transmitted not by direct contact, by through a vector like dengue, okay, malaria. So the vector there is the the mosquito, okay, or cysto, where the vector there are what do you call these? The snails, okay, that are found in bodies of water. Okay? So again, we can look at the models or the compartments where uh, we try to have uh, compartments and a particular flow from each compartment. Okay, and that flow will be considered as what we call the rate at which a particular or the population in the compartment is moved to the next compartment. Okay, a simple SI model is shown here, okay, where we try to divide the population into two compartments, susceptible and infected. And when we do modeling, we always start with a very simple one, okay, and try to build from that simple model, okay, because again, we first have to be or we need to practice or at least have an idea on how we uh, construct the real world problem, okay, and then translate it to the math world. Okay, and as much as possible, starting simple and start with the simple ones, understand it, okay, and from there we can build from the simple models. Okay, and in this particular diagram, it gives you a flow of susceptibles into infected. Meaning, if you look at S dot, so it goes back to course in calculus wherein you're dealing with the rate of change. Okay, so this denotes ds over dt or S dot. Okay, and in this particular case, it means that in a disease, then in a population, if there is an if there are infections, then some of the susceptible gets infected. Therefore, the rate of change would be negative, meaning uh, outward. Okay, and then for the infected compartment, it's positive, meaning it's the inflow of from the susceptible into the infected class. Okay. Okay. Next would be what an extension. So what from the simple one, we can now try to build an SIS transmission model. Okay, and only difference here is again getting to have the infected, some of the infected compartment gets to what you call this recover. Also, already they get the disease or they get the disease, and a few days they go back to the susceptible class. Okay, and this can be seen from a simple uh, colds, okay, or flu, wherein you get to have the infection, and a few days you recover, and in a few days you can still get again the colds or flu. Okay, so it depends on the particular model that you are disease that you want to model. Okay, so again, uh, we can have it extended wherein you will have susceptible and then infected and then possibly a recovered class. Okay? So most of the time we try to have an explicit solution to this kind of system. So you have two differential equations, and we would like to see the dynamics of this system and try to solve it, okay, analytically. So we're assuming here that certain conditions are satisfied. Okay. Okay. I again, it's going back to uh, your maybe calculus course where you try to solve differential equations. Okay. So why do we do this? Again, we would like to uh, come up with the solution, and hopefully it will give us an idea on the real world problem that you would be trying to understand or study. Okay. Okay. So again, equilibrium points are what you call this. Again, if you have a particular disease, then some diseases happens to be endemic, meaning uh, they don't disappear through time. Okay, so just like what uh, malaria. Okay, so again, if you will see, malaria is a disease wherein is still endemic and still found, okay, in some areas. Okay? And we can try to look at the relationship of the disease in terms of what you call the weather. So there's some seasonality in this particular disease. Same thing with dengue, wherein what you call this, uh, it is said to be endemic. Okay, uh, maybe polio is can be considered wherein, uh, but that's why if you look at diseases, uh, it is really interesting to look at it if it's a disease which can be seen to disappear through time, or it becomes an endemic where it still thrives through time. Okay, so this gives us different modeling approaches to this particular diseases. Okay, so there are certain diseases it becomes endemic, but at some point it was able to or uh, uh, it disappears through time. Okay, so most of the time you will look at these uh, points, okay, where we will be able to see or look at the parameters, or yeah, the parameters in the model that you can try to control in order for you to either have the value for the endemic points. Okay. Okay. Simple SIR model. Again, we did look at an SI, and then we can extend it to an SIR model. Okay. And from here, again, we can look at assumptions. Okay. And from the assumptions, then we can try to formulate the differential equations that governs the model. Okay. So from here, I think that's the usual process that you have to go through. Okay. You can construct ordinary differential equations. Okay. As we have mentioned, here populations is well mixed. So there's an assumption in stated here for the math world to work. Okay. So again, from the diagram, maybe you can try to look at the equations and then keep track of the inflow and outflow just to see if you have the correct terms. Okay. And after which you try to do uh, try to solve the problem, okay, or possibly alter the model if you want to include other factors. Okay. So I am now looking at a very simple one, okay, where I look at SI to be a negative beta sub SI, okay, or simply what you call the transmission rate. So why is it negative? We expect that if there's a disease, then obviously you have some decrease in the what you call this in the susceptible population. Okay, so the decrease in the susceptible population would mean that if you look at I dot, which is beta SI, okay, or beta S sub I for the transmission, okay, it becomes positive. Therefore, there's an increase into the infected class, okay, and at some point, obviously, you will get maybe some of the infected will recover. Therefore, it moves to the recovery class. Okay, so you have this very simple uh, SIR model. Okay, so I think let's now try to shift and see how we would uh, analyze, or rather construct, a visualization of the SIR model, since we would be interested in solving, or rather approximating, the time series of your susceptible, infected, and recovered class. Okay, so here, if you have GeoGebra with you in your Android or in your laptop, you can just run GeoGebra. It gives you this one. Okay, let me what you call this? Have the view. So I started using GeoGebra around 10 or 20 years ago. And it's nice to encounter that one of the tools now, which was done obviously by mathematicians, because that's how you would try to solve the problem numerically, and the iterative steps that were constructed is integrated into the what you call this, into the package. Okay, so let me just check the layout. I would like to have the command. So here, I will just use the input command. Okay, so I'm now trying to, okay. So here, the first thing when we look at a model, so we consider a disease where we try to divide it into three compartments, just like what we have shown in the system of differential equation, which denotes S dot is the rate of change of the susceptible class, and then I dot is the rate of change for the infected class, and then our compartment, and then R is the rate of change of the recovered or sometimes removed class. Okay, so it depends on how you will term it, but most of the time they would look at it as remove or recovered class. Okay, and later on, if you want, if you would like to have a smaller scale or a smaller time frame, that's why again we can look at a particular disease wherein maybe it's more appropriate to look at the problem in a shorter time frame, okay, meaning dividing it into more appropriate, more number of compartments. Okay, and here again, let's look at the model where it's beta Si. Okay, so the transmission rate, uh, the first term S dot, I dot, and R dot. Okay, so let me look at what initially, if you look at the population, maybe we can start with the total population to be equal to 1. So Y1, it's like a percentage in terms of the percentage. So it's easier to work in terms of proportion of the population. Okay. Or if you want, you can have actual numbers. It's still okay. Okay. So let me go back to the steps that we need to do in try to solve the system of three differential equations and try to simulate it. So I put enter. So you have constant n equals 1. So assumption here is the total or total population does not change. Okay. Next are set sliders. So when I say sliders, it's a way of trying to change the values. Okay, as you move the knob. Okay, when I say knob, it's just like your slider. Then you're automatically changing the value of that particular parameter. Okay. Uh, what are the sliders? Beta. I will call it beta sub or any. So I will put beta. Okay. So let's create slider for that. Meaning I can try to change the values of B. Since B is, if you want, you can change it like what? We can change the name. What? Just to easily remember it, because beta is the transmission. So maybe let's look at it as what? Trans. Okay. And then again, if you look at the properties, I think appropriate would be what? Since this is a value, let's just look at starting with 0. Okay. Okay. So you can just use a slider for this one. Next is looking at the equation. That's beta Si, or the transmission rate, and the other parameter is R, or the recovery rate. Okay, so again, we can look at a slider for this, and then recovery. Okay, reco. Okay, so oops, sorry. There's a function recov. Okay, recov. Create a slider. Okay, so again, this is the parameter, okay, that you multiply to what you call this, to I. Okay, so it's the the second term in your differential equation. Okay, so again, maybe let's look at this as recovery rate would be smaller, maybe because you can have 1 or 2. Okay, or depends. Let's just make it recovery smaller compared to the transmission rate. Okay, so once I have that, what's next? I can have other sliders like the time frame. So if you will see, depends on the units. So the units can be changed later on in this particular example. Then these numbers might represent units, depends on how you will interpret the problem. Okay. So another slider would be what I will call it max time. Okay. So maximum and maybe let's look at the time to start from 0 and then around 25 or 30 days, depends. Okay. So from here, again, we now have 3 sliders, okay, that were created. And then the next one would be what? Population, initial populations, meaning the initial condition for your compartments. Okay, so initially I maybe I sub 0, or sorry, yeah, I sub 0 is your initial population which are infected, maybe around 1%. Or yeah, 1%. And then susceptible initially would be what? We can look at S sub 0, which will be equal to the total population minus I sub 0. Okay, or you can just put it as 0.99. Okay, so if you are to look at the situation, maybe you can have 100 people in a, what you call this, in a room where one is initially infected. Okay, and what's next? Population, and then what are the 3? Sorry, SIR. Okay, I still have R. Okay, so maybe R sub 0 will just be 0. Okay, so you will now have the total population to be 1. Okay, next would be the variables, and the variables there would be S, I, and R. Okay, so I will now create the system of differential equations. Usually this is what SI, and it is in terms of time t, and then S I R. Okay, and this is what trans times S times I. So if you look at your differential equation, this is the transmission value times the susceptible and infected. Okay, so again, since you are having infections, therefore the susceptible decreases, so you get minus rate. Okay, so the rate is negative trans SI. Okay, and you do the same for the other 3 differential equations. SI dot of T comma S comma, sorry, I comma R, okay, which is equal to what? Again, this is the I dot, as you will see, that is trans, so times S times I, okay, minus what? Some of them moves to the recovered class, so I think we use recov. okay, times I. Okay, and last is the recovery rate, or the third differential equation, which is S I R, okay, which is equal to uh, what? Plus. Okay, so that's plus rec of times I. Okay, so you have three differential equations in here. Uh, so let's try to check trans times Si minus. So you will see that in the command prompt for GeoGebra, you either put a asterisk or just put space to denote multiplication. Okay, so you get the three. Next, we now try to make use of the built-in function of GeoGebra. So these are the built-in function that was incorporated by people who have integrated uh, NSolve. Okay, so it makes use of RK4, the usual integrating tool. Okay, that is being used. Okay, so how do we solve this? So you can now make use of NSolve. Okay, so you will see that you have NSolve ODE. Okay, so NSolve ODE. Okay, and it will give you how many arguments? One, two, list of derivatives, initial coordinate, list of initial y coordinates, and final coordinate. So here I will have to group them into three. Okay, we will use uh, what? NSolve, which are what? Are the three system S prime, I prime, R prime. Okay, and then initial x coordinates, meaning your initial uh, time. Okay, so your x there is the time, so you get 0 initially, and then list of y coordinates are your we're now looking at the time series of S population S, I, and R. So this will now be what? The initial values of your Y would be, so we now use curly brace to group the three. So that's S sub 0. And then Y sub 0, the initial values, sorry, S, I sub 0, and R sub 0. Okay, and then the final X coordinate is your max T. Okay, so if you look at this one, you are able to come up with three, okay, solutions already. Okay, so initially you will have this one. Let me just move this. This is the scale. What? Move the mouse. Gosh. Yun. Okay, so now maybe just to see the difference of the three graphs that will be generated, we will now try to change the color of the following. Okay, for S, color would be susceptible, would be what? Green, maybe. And then for the infected is will maintain the red. And then for the recovered would be blue. Okay. so that this will still be green. This, oops, sorry. And so initially should be should be green, and initially recovered. This is the blue. Okay, and this would be the red. Okay, so you will now see that as I move the what you call this slider for the time of simulation will now give me a time series of your three uh, compartments of the population. Okay. Okay. So here, what's nice is you can now try to have an idea what's really happening to the disease through time. Okay. And again, sometimes I'm sure you have looked at what, or you've been hearing about flatten the curve, okay, or flattening the curve. Okay? And in this particular case, maybe we would like to see this one, which happens to be your infected compartment, okay, to be flattened in such a way that you will really minimize, okay, the peak, meaning the maximum value that the infected population will reach through time. Okay, and maybe if you have heard also, you always hear what you call the R naught. Okay, so uh, R naught is defined as what, the number of new infections that gets to happen from one infected individual, okay, in a totally susceptible population. And what's nice again is if you have this, okay, meaning I can now try to simulate wherein I can start at different values of infected, okay, class, and see what happens to the dynamics of the disease. Okay, and again, it's not as simple as looking at this one. It's also nice to instead of doing number crunching, this is trying to do some number crunching, wherein if you look at this time step, maybe I can look at what this would be the first day, okay, and then this is initially, so the next day will be giving me this one, and you can solve it by going back to iterative process wherein the population tomorrow of susceptibles will be given by the population today plus the rate of change of S, which is your S dot times 1 day. Okay, so you will have the iterative step wherein you get to have this one. So the only difference here is that if you look at the result when you do the number crunching or the time iterative step will give you unrealistic. When I say unrealistic, it's not possible like having let's say 2.3 humans moving there. Okay, so it gives you just an idea wherein 2 person and then 1/3 of or 2.3 will be 2 and 1/3 will get infected. Okay, so later on we will see the difference of agent based where if we are to simulate the SI model or SIR model, it will just give you what you call integers. Okay, okay, so if I were to look at the R naught, maybe we can just define R naught. So it's not, I'll just R0, okay? Because sometimes you get confused with R naught to be the initial value of the recovered or removed class. And R naught is just, can be solved as what? Again, it's just in this particular model, it's just the ratio of the infection rate, which is trans, okay, divided by recov. Okay, and if you try to so if you look at this particular example, it gives you now R naught is 2.5, okay, and you will see that you can change the value of R naught depends on the values that you get to have in the transmission and recovery rate. Okay, and maybe just to give you some analysis of this, if I were to look at this one, okay, so if I were to have an analytical way of looking at it, if you were a policy or a public policy person, okay, what do we do? Okay, so here, if you will see this one, I can factor out what you call this I. So this becomes beta S minus R. Okay, so the trans minus recov. Okay, okay, so trans times S minus recov times I. So if you look at that particular factor there, meaning that gives me now an idea of looking at what the possible values of I naught, okay, or I dot, okay, and if you were to see, this gives you a value wherein I can try to compare S. So from that factor, S will just be equal to some R or the recov over trans, okay? And that will be what you call a threshold, okay? So again, from the threshold, I can look at 1 over threshold as the value of R naught. Okay, so from the threshold itself, you will see now that if the threshold, which is recov over trans, okay, is less than what? Maybe you can try to see. Let's see. I don't have values, or you can try to look at threshold. Okay, so if S is less than the threshold, then there will be no epidemic. Okay, and if S is greater than the threshold, then you will have an epidemic. Okay. Okay. Looking at that one, I think this is where you try to study what you call the transmission rate or the transmission coefficient, trans, okay? And if you want to decrease the transmission rate because you want to have no epidemic, meaning S here, okay, S should be less than threshold or recom over trans, okay? So how do we do that? How do we decrease transmission or the transmission rate, okay, in this particular disease that we have currently? In order for you to what you call reduce transmission rate, meaning what? Washing hands, okay? Avoid contact, meaning using, or avoid the transmission, meaning using face mask, okay? Maybe stay home, okay? Or social distancing. So that's how you would decrease the trans value, okay? And the other one, so what I'm trying to say now is the other one is for you to have S less than threshold. Maybe you can have to decrease S, okay? But is that possible? Before you can only do that if you will have or you cannot do that, okay, because you have the epidemic. Okay, what we can do is before the epidemic. So for before the epidemic, in order for you to decrease S, then what you can do is provide vaccines. So providing vaccines means you are trying to reduce the number of susceptible uh, people. Okay. Or the other one in that particular case is what? You are to increase recovery. So here, what we're trying to do now is one is to decrease the transmission coefficient, beta. Okay? Meaning, if you do that, then you're trying to have lower value, okay, for the disease, wherein you will now see that the trans here is some sort of you're able to flatten the curve. Okay. So if you look at this one, what it says is, maybe if you look at this as days, maybe on the first 3 days, you get to have almost 30%, okay, of the population getting infected. Okay. And if I were to uh, impose possibly what you call this before the one, if you are to impose certain conditions, okay, meaning you want to decrease the transmission rate, okay, then you will see that most probably you are able to flatten the curve and expect that uh, around 20% will get infected, uh, or get it, the maximum infection will reach on the fourth day. Okay, so and then what do we do with recovery rate? So usually, if you have that one, meaning recovery rate, you are to apply or provide medication for those who are infected, okay? Or maybe provide healthy food for them to recover faster. Okay, so in that case, maybe you will see that if suppose you have this, okay, recovery rate is zero point 0.8, and you get to see this one. So at around the maximum is 30%. Okay, but what happens is you can try to flatten also the curve by increasing recovery rate. Okay, and this is what we call your R naught. Again, what we want to do is at the same time when you adjust the transmission value, you are trying to what you call this, reduce R naught. Okay, so that is why a lot of people would talk about the reproductive uh, or yeah, the number of new infections. Okay, so R sub zero. Okay, so maybe that's where you will now see that, okay, what will I do? I can play around with this. So when you play around with this, it means that on the what do you call this, on the real scenario, what you're trying to do is impose certain conditions for you to be able to what you call this, change the transmission value here. Okay, so it gives you now an idea wherein if I have this situation, maybe you will say that we if you reach around 5 or 4.7, or if you reach around 5 or 6 reproductive number, you will see that, or maybe at, if you have an R naught of 5.33, then you will reach to have, or you will get 50% of the population getting infected, most probably in this time, or in this yeah, in this time. Okay, so again, that's why they see what you call the flattening of the curve, means you try to impose certain conditions in the model for you to change the parameter values. Okay, so this tool is again just a tool. It has limitations, but it can help you visualize what's happening in what you call this, in the model. Okay, Okay, so next is you can have extended into four compartments, and you might have SEIR, okay, model, and maybe just to, I have already uh, uh, SEIR demo. Okay, so if you look at this one again, it's the same as just trying to construct what you call these four differential equations, and the four differential equations uh, can be the simplest four differential equations written here. Okay, just like in the SIR, except that you did try to add this, which means that you have the transmission rate, and you get to have what you call the exposed class, wherein you don't still get to transmit the disease, right? That's why in the case, I think, of COVID, wherein they say that you get infected at some point the first few days, you haven't maybe you are not yet infectious, but after 3 to 5 days, you get to have the disease really, and get to infect other people. Okay, so uh, in trying to model certain problems, then maybe you can try to change the parameters beta, the transmission a here, where this parameters is a function again of what, of certain parameters. Okay, that you will be able to maybe see or observe from data. Okay, so again, you get to have some data in such a way that you will be able to have a better model for those parameters. Okay, so you can have a function also of here. Okay, so if it's a function of certain parameters or variables, then it will be uh, different, because again, this model will just be tackling a simple one. But maybe if you are interested and you want to contribute, then you can have the parameters here as a function also of other variables. Okay. Okay. So uh, that's how we try to model maybe a simple SIR and then extend it to SEIR. Okay. So maybe I will continue with the rest of the talk, okay, wherein maybe we will just try to provide other models or other extensions that you might consider if you want to work on disease dynamics, okay, and possible directions that you can take. Okay, so maybe I'll just first end the talk here. Okay, if you have your GeoGebra, then play around with it. Okay, just follow as we have mentioned, wherein you create the population, just to summarize, the sliders for the parameters, okay, and then the initial conditions. Okay. Initially, the initial condition for your differential equation, and then the system of differential equations. Okay. Okay, and if you want to have this being used by your class, maybe for other people that they would want to play around with, then make it more interactive. It can easily be uploaded as what do you call this, an applet in your website, or just share. Okay, this one. Okay, so you can have other interesting things like putting in questions here, where it becomes interactive. Okay, or they can change the initial population, and possibly also visualize this particular point. Okay, so if I were to look at this one, then I can have an animation wherein it will just keep on changing P, okay, and try to uh, see what's happening in the graph. Okay? And again, let's stop here. It's 11:30. I'll see you. I think what's the next? I think it's 1:30 ba?
Hello po, sir. Sir, it's 1:15, but
Okay.
before the second parallel session for MSP members, we have MSP meeting po, which will start at 12:30, but they can enter at exactly 12 o'clock po ng hapon po.
Okay. So again, let's stop here. Thank you. And let's continue with the workshop, okay, at 1:15.
Let us give Dr. Adawe a round of applause po.
Or do
And
you have, yeah, I
my
think there are some
questions po.
Any other questions you want to raise? Wala? Okay. So yeah, if you have what you call this interactive slides or interactive problems, okay, or codes for GeoGebra, you can share it. You can easily upload them and share it. Okay. Okay. So again, thank you, and I'll see you later.
Hello everyone, but basahin lang po natin yung naka-flash. So if you wish to join or the Mathematical Society of the Philippines, here are some frequently asked questions. So first, how can we become an MSP member? So the answer here is to consult any MSP member. And to those coming from CAR, Region 1 and Region 2, you may email Prof. Isabel Adawe in her email rcadawe@up.edu.ph regarding the membership form. But the membership form is posted po dito sa ating chat box. So for regions 1, 2, and CAR lamang po ito. Is receipt provided after payment of MSP membership fee? Yes, and then the receipt will be emailed to you by Prof. Adawe. Does MSP release a certificate of membership? The answer here is if the application is approved and payment has been made, you will be given a certificate of membership. Next year, will SINSM be conducted face-to-face? Although medyo nandito po sa ating slide, we are hoping that next year we will be conducting SINSM 2023 face-to-face po here at UP Baguio. Then meron din po tayong common question. Stop share screen ko lang po. And flash ko lang po siya.
Okay, Sir Joy. Iwan daw kay Sir Joy. Iwan na talaga kay Sir Joy.
How much po is the MSP membership fee? As of June 2022, MSP membership fee is 500 pesos per year po. So meron po tayong renewal fee din po, which is 500 din po. For application or renewal of membership, please visit the link given by this one. Nandun din po siya sa ating inbox. And thank you very much. Happy lunch po sa ating lahat.
Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine business and networks office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Baguio is built on a pine-clad hill in the heart of Baguio City. For 50 years now, since its establishment in 1961, UP in Baguio has worked at serving as the lead institution in the delivery of tertiary education in Northern Luzon, sustaining its efforts at modernization, the strengthening of curricular programs, and the active generation of knowledge through research. UP Baguio is also a green campus in the true sense of the word, with all sectors committed to the preservation and planting of various trees and plants within and around the campus. It is indeed as the UP in the north that UP Baguio has quite proudly evolved into, carving out a niche in Cordillera studies developed over the past decades. The Department of Mathematics and Computer Science, or DMCS, was first established as the discipline of the Division of Natural Sciences and Mathematics, or DNSM, in 1961. The DNSM was then reorganized as the College of Science in 2002, consisting of 3 departments, namely Biology, Physical Sciences, and Mathematics and Computer Science, and 1 Human Kinetics program. It is the mission of the department to adhere to the highest standards of excellence in all aspects of teaching, research, and extension service. This year, the DMCS ranked #1 unit in UP Baguio according to the UP System-wide assessment called the Internal Academic Assessment and Development System, or IADS. Currently, the DMCS offers 4 academic programs, 2 in the baccalaureate level, namely BS Mathematics and BS Computer Science, and 2 in the graduate level, namely Master of Science in Mathematics and the newly instituted Doctor of Philosophy in Mathematics. The department's extension programs, recognized and endorsed both by the Department of Education and the Commission on Higher Education, span capacity-building activities in mathematics teaching and research that service secondary and tertiary institutions in the North and Central Luzon and other parts of the Philippines. These programs include It is the objective of the department to strengthen its graduate and undergraduate programs, aggressively promote and maintain standards of quality education, and to lead in research capability building and research generating activities in the mathematical and computing sciences and mathematics education. Together, the department will continue to maintain nationally and internationally recognized expertise in core, as well as emerging areas of mathematics, statistics, and computer science, and make it accessible to the people in the region. UP Baguio is built on a pine-clad hill in the heart of Baguio City. For 50 years now, since its establishment in 1961, UP in Baguio has worked at serving as the lead institution in the delivery of tertiary education in Northern Luzon, sustaining its efforts at modernization, the strengthening of curricular programs, and the active generation of knowledge through research. UP Baguio is also a green campus in the truest sense of the word, with all sectors committed to the preservation and planting of various trees and plants within and around the campus. It is indeed as the UP in the north that UP Baguio has quite proudly evolved into, carving out a niche in Cordillera studies developed over the past decades. The Department of Mathematics and Computer Science, or DMCS, was first established as the discipline of the Division of Natural Sciences and Mathematics, or DNSM, in 1961. The DNSM was then reorganized as the College of Science in 2002, consisting of 3 departments, namely Biology, Physical Sciences, and Mathematics and Computer Science, and 1 Human Kinetics program. It is the mission of the department to adhere to the highest standards of excellence in all aspects of teaching, research, and extension service. This year, the DMCS ranked #1 unit in UP Baguio according to the UP system-wide assessment called the Internal Academic Assessment and Development System, or IADS. Currently, the DMCS offers 4 academic programs, 2 in the baccalaureate level, namely BS Mathematics and BS Computer Science, and 2 in the graduate level, namely Master of Science in Mathematics and the newly instituted Doctor of Philosophy in Mathematics. The department's extension programs, recognized and endorsed both by the Department of Education and the Commission on Higher Education, span capacity-building activities in mathematics teaching and research that service secondary and tertiary institutions in the North and Central Luzon and other parts of the Philippines. These programs include It is the objective of the department to strengthen its graduate and undergraduate programs, aggressively promote and maintain standards of quality education, and to lead in research capability building and research generating activities in the mathematical and computing sciences and mathematics education. Together, the department will continue to maintain nationally and internationally recognized expertise in core, as well as emerging areas of mathematics, statistics, and computer science, and make it accessible to the people in the region.
Pwede naman doon. Hindi ka kasha. Hindi sambang yun. Dapat na eh.
UP Baguio is built on a pine-clad hill in the heart of Baguio City. For 50 years now, since its establishment in 1961, UP in Baguio has worked at serving as the lead institution in the delivery of tertiary education in Northern Luzon, sustaining its efforts at modernization, the strengthening of curricular programs, and the active generation of knowledge through research. UP Baguio is also a green campus in the truest sense of the word, with all sectors committed to the preservation and planting of various trees and plants within and around the campus. It is indeed as the UP in the north that UP Baguio has quite proudly evolved into, carving out a niche in Cordillera studies developed over the past decades. The Department of Mathematics and Computer Science, or DMCS, was first established as the discipline of the Division of Natural Sciences and Mathematics, or DNSM, in 1961. The DNSM was then reorganized as the College of Science in 2002, consisting of 3 departments, namely Biology, Physical Sciences, and Mathematics and Computer Science, and 1 Human Kinetics program. It is the mission of the department to adhere to the highest standards of excellence in all aspects of teaching, research, and extension service. For this year, the DMCS ranked #1 unit in UP Baguio according to the UPB-SysNet assessment called the Internal Academic Assessment and Development Center of Science in is endorsed both by the Department of Education and the Commission on Higher Education, span capacity building activities in mathematics teaching and research that service secondary and tertiary institutions in the North and Central Luzon and other parts of the Philippines. These programs include It is the objective of the department to strengthen its graduate and undergraduate programs, aggressively promote and maintain standards of quality education, and to lead in research capability building and research generating activities in the mathematical and computing sciences and mathematics education. Together, the department will continue to maintain nationally and internationally recognized expertise in core, as well as emerging areas of mathematics, statistics, and computer science, and make it accessible to the people in the region.
Ganun.
Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar except for the moderators and speakers should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar except for the moderators and speakers should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP-Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled. During the open forum, all those wanting to ask questions should send their queries via the Q&A function of the Zoom webinar or in the comment section of the YouTube streaming. The moderator will determine if follow-up questions can still be accommodated or not. After the webinar, the participants are enjoined to accomplish an evaluation form. The link of the said form will be posted on the chat feature of the Zoom meeting and the comment section of the YouTube streaming. The technical team will determine which among the questions sent will be read by the moderators and the order in which they will be asked. The moderators will acknowledge the member of the audience who fielded the particular questions, and participants may be asked to unmute, turn on their camera, and introduce themselves for the Q&A. The College of Science SINSM Committee wishes to thank the UP Baguio System and Networks Office for their enormous support for this event. Thank you, and welcome to the 27th Summer Institute for Natural Sciences and Mathematics. Here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation. here are a few reminders for our 27th Summer Institute for Natural Sciences and Mathematics 3-day webinar. The entire proceedings of this webinar will be recorded for documentation purposes. All attendees of the webinar, except for the moderators and speakers, should keep their cameras switched off and their microphones on mute during the webinar and subsequent open forum. In case the webinar is interrupted due to a technical problem, all are asked to wait for 10 minutes to give the meeting hosts time to resolve the issue, or in the case that the problem cannot be fixed, to announce that the webinar will be rescheduled.
Good afternoon, everyone. I hope you can hear me clearly. Before we start, welcome to the second, actually the last parallel session for the SINSM Mathematics and Computer Science cluster. And today we will be continuing the talk of Prof. Adawe entitled Introduction to Agent-Based Modeling of Disease Dynamics 2.0, and some special announcement for all MSP members and aspiring MSP applicants. A special MSP assembly will commence after the closing program today. Thank you. Hello, sir. Good afternoon po. Okay na po ba, sir? Hello, sir. I think hindi po ata naririnig yung audio, sir. Hello, sir. Sir, no sound. No sound po in my end. Hello. Sir, no sound po. Let's just wait po for... Hello, sir. Ayan. Ayan, sir. May counting... Sir, wala pa rin pong audio, sir.
Okay.
Ayan. Meron na po.
Sheldon.
Yan, meron na. I'm using the thing. We just shift to the computer. Better to shift the computer speaker. Okay, so you can hear me?
Yes po, sir. It's loud and clear po.
Hope I don't have barking dogs out beside me or sound. Anyway, so let's try to continue. Let me share the screen now. So you can see, I think we've done this one, where let me go back to the slides now. You're seeing my slides. Again, what we did was construct the SIR and then SEIR. Can you now see my slides?
Yes, sir. May nakikita po kami.
Motivations for new models. This is where once you have the simple model, you can now look at the different modifications that you can work on. Okay, and again, it's not as simple as trying to simulate it, but rather doing the details on how you would be solving the system and describing the dynamics. So we will be dealing with a lot of analytical uh, a way of solving the system, and then trying to interpret the solution in terms of the model. Okay. And again, one motivation, as I've mentioned in this paper, which we have done before, was structuring into what you call age. Okay. And as you can see, going back to the data that we have shown earlier, where the disease like malaria is caused by a vector, and it was observed that uh, majority of the uh, the age, okay, or yeah, the age, the demo of the humans are into what you call the age bracketing. Okay, so in COVID, I think we can look at let's say having a structure where we separate compartments for the senior uh, human population, and then we can also look at children, which I think are not yet allowed to be vaccinated, like ages below 5, and also consider where you have vaccination for only 2 doses for age 5 to 18. Okay, so these are things that can be incorporated in a new model that you would like to work on. And again, as I've mentioned, it's different for different types of diseases. Okay, like diseases which happens to be endemic, meaning it will not or it was shown that it will exist through time. Okay, unlike some pandemics that will occur but will disappear at some time. Okay, so here motivation of the new models, as we can see, we can introduce different vectors, and again, the vectors could be in terms of what they call an animal. Okay, just like as I mentioned, dengue, malaria, and yellow fever. These are uh, very active researches that are being done because of its effect, especially in some regions like South Africa. Okay, and it was observed that what do you call this? It was observed that uh, several affected group of people happens to be or affected people that cause death are on the children population. Okay, so here this is where you can try to think of incorporating, as I've mentioned, other compartments, and then possibly also dealing with what other parameters, okay, not where parameters can be some function of time. Okay? So this is where you can see that new models arises different locations. And it is always nice that when you model, you try to get closer to what you have, meaning around you, and possibly a way of helping also the region that you are located. Okay, so again, just to give you an overview, here age structured means we just try to divide the human population, okay, into children which are considered preschool, okay, that's 0 to 5, and then the rest. Okay, so one thing that you can also consider is to have the age into 3, meaning maybe 0 to 5, and then 5 to 18, okay, and then 18 to or 18 above, okay, and that can give you way of analyzing if really the demographics for the age structuring would make a difference. Okay, so that's one. And then again, when you construct your model, it is always helpful to have what you call compartments, or rather your flow diagram, in order for you to easily check the correctness of your system, at the same time the model and assumptions that you have constructed. Okay? And parameters, again, start with a small set of parameters and extend it to be more realistic if you want to. Okay, and the analysis makes it more difficult if you have more equations and more parameters, thus resulting to most of the studies only to what you call this numerical simulations or numerical approach. Okay, so you try to study again, as we have seen, the dynamics of the disease. Okay, and the parameters that you try to make or to use should always be what you call this, should always be based on data. So again, data is very important because it makes your model closer to what is really happening. Okay, so I will not go through the details of this. We have done GeoGebra at work, so I hope you've tried doing it during the break. And if you want, you can what do you call this? Send me an email if you have some questions in relation to how it is to be done. Okay, so that's the difference now, wherein what you call face-to-face and remote would be what we cannot have it in a lab. Thus, I hope you have your own test machine that you can work with. Okay. So once you have installed it, I think that's the advantage of GeoGebra, wherein it's easily installed. Okay. Now let me shift to modeling, an alternative way of modeling disease dynamics, and in this particular part, we will concentrate on an open, or rather an open source, and also very popular in the modeling of what you call these streets. Okay, so it was really motivated by the mapping of what you call humans and cars being simulated in a city. Okay, and what is nice with this is it makes use of what you call maps. Okay, so with the use of maps, then it is able to get closer in simulating the dynamics that occurs in a particular location. And in this case, we'll try to see how it can be used in a small portion of Baguio. Okay? And if you want it to be more realistic, that is why if you search on the developers of Gamma, they're now able to come up with toolkits that's being used for creating what they call smart cities. Okay, and for me the disadvantage only is that it requires a better powerful machine because of the computing that it has to go through, especially in the use of graph. Okay, so it runs also. If you look at this is the Gamma platform, And it has, again, some comparison where it is compared with its GIS capabilities. Okay, and you will see that only a few are able to make use of GIS data, and some of them I think are not open source, okay, and they're proprietary. But one what do you call this one popular agent-based platform also that is being used is NetLogo. Okay, so if you get to see this one, it's I think developed that started in the US, while the Gamma started in a group of people in France. Okay, so here it runs on Linux and Mac, okay, and in Windows. Okay. Now, if you will see, they have, I think, the latest version, which is 1.82, but I'm not so sure if it's really stable. Okay. And it's still being developed. As you can see, it's an active community being shared by several people who are working on Gamma. Okay, and once you start working on it, and if you have questions, then you just have to post it in the group. Okay, and sometimes these developers, especially the group of Dragul and people in Vietnam, are really active in answering those queries. Okay. Okay, as I think we have already mentioned this one, ABM, or an agent-based modeling, is able to deal with, when you say more complex, like in a simple SIR, okay, meaning the compartments will now be able, or each compartment can be, what you call this, more, have more characteristics to deal with, okay, in order to get closer to what you call the things that are happening in the problem. Okay, so here you will now use ABM. Okay, and most of the things that you will see happens to be when you say nonlinear. Okay, then it's more difficult to solve. Okay, and in trying to solve, or rather simulate the dynamics, then you just have to make use of what you call agents. Okay, okay, again, we will start the next discussion will be a simple demo on how we start working on a simple SI model, or rather a simple model first to start with. Okay, so it's some sort of a tutorial on how to use a Gamma. Okay, and later on you can try to make changes and hopefully explore the other capabilities of Gamma. Okay, as we can see, you will now be able to see that in Gamma, okay, it has three main sections. Okay, this is the skeleton of the code for Gamma. Okay, so one is the global, the species, and the experiment. So it's like here, when we look at global, it's the section that could be what you call the world, okay, of an agent. Okay, so this is where you have to define the dynamics, the variables, and the actions, okay, in the world, okay, of the agent. And then the species is where you define the agents, okay, that compose the model. And in the third, or in the section where you define the execution, okay, and define the input and output of your simulation, like displaying the maps, okay, displaying the agents. You can have either in first is to start with agents as simple circles, okay, and later on, if you want to be more realistic or visual, then you can change those figures into what you call just like playing some games. Okay. Okay, so let me shift now. Again, when you look at gamma, so you can just search for gamma, okay, and then you can download. So from the web, we can just click gamma and then gamma agent based. Okay. So take note that you just search this one and it gives you the Gamma platform. Okay? And again, you have active community that gives you tutorials and the recent versions where they try to incorporate uh, epidemics, where they try to incorporate also, just like the GeoGebra platform, where the ODE NSolve ODE command is available, while in Gamma it was recently added where they integrate some sort of a library that tries to compute for the numerical integrations, like what RK4. Okay. Okay, tutorials, as you can see here, and then for the Gamma platform, you just have to download the correct version for your a particular platform. Okay, so if you're using Windows, then you will be downloading an exe file, okay, because in Linux it's also different. Okay, so for Mac, I think it's a DMG file, but most of the time you can compile it from source. Okay, and if you look at Gamma platform, again, the logo itself is again looking at the concept of agents, wherein it is composed of points, or rather circles or polygons, okay, that are seen, okay, and tries to simulate, in this particular image is a city, okay, and there are some limitations, especially on the maps. Okay? So you have to be aware of those limitations, because sometimes if you have a very complicated map, okay, then it has some difficulties in the computations, okay, that has to be done. Okay, and when you download, and it will just give you what the different versions for that one. Okay, so for download, again, I would prefer that you download this version if you're using Mac. Okay, easiest version to run, no need to install anything. Okay, except that I just have to compile, or rather click and uncompress, and automatically installs. Okay. For Windows, is the same, and as you can see, you get this one. Okay, and if you want to contribute, then most probably you will need to look into what they call the daily build, where you try to integrate your what they call this, your contributions. Okay, you have a PDF documentation, like in this case, which is used for offline, but for online, you still have that one. Okay, so if we can see that current version is still 1.1, stable 1.1, but they're coming up with 1.2. Okay, just to give credit, as you can see, you have a lot of applications in this particular case. Okay, and the people behind this are a group of people, research team in Vietnam, okay, and Paris. Okay. So just to give credit, these are the main people that are working, okay, on this platform. So this guy, Durkul, is I think the main person that have started this package. Okay, and this guy here is from Vietnam, because in Vietnam they have now a group, especially in the math department, that are trying to contribute in the libraries, okay, of Gamma. So they're more in the mathical aspect that can be covered or integrated into Gamma. Okay, so again, gives you an idea wherein you can make use of shape files, okay, and happens to deal with 3D and 2D. Okay, if you have a 3D version, then it considers elevations for the movement. So you can now look at movement vertically and horizontally. And what you need to understand here is when we model, okay, we have to go back to the basics where, again, just like what we did earlier, what are the main features that we need to consider, okay, in describing the dynamics of the model. Okay, let me now proceed with how once you install it, so you just click on download, okay, and then so this one is downloaded. I downloaded it for Mac, and once you download, then we can now try to run Gamma. Okay, so I just type Gamma, and from your first installation, you will see that it will ask you for a workspace, and this is the folder most probably you will be putting your working documents. Okay, but you have to be careful that again the links. Okay, so the folders are quite connected to each other, and the library of all those the package that you need to run Gamma. So here I created a folder. I used CSU because I had a lecture earlier with the Cagayan State U in relation to the same approach. Okay, and once you click OK, it will prompt you. Okay, the workspace contains different version of the models library, so you just ignore it. Okay, I will just proceed anyway because I did try to create my own folder. Okay, and if you run this in a laptop, depends on the specs of the laptop, quite takes a long time to load. Okay, so here you now have the Gamma platform. Okay, and you will have the main windows that you will be using are this one. Okay, the upper left, this is where you get to write the code, and this is where you can write the commands. Okay, in the terminal, it's like the terminal mode. Okay. Okay, so once you have this, usually if you run it for the first time, the user models here is zero project. Okay, so you have to create a project for your own work. Okay, so usually when you run it, the user model gives only zero project here. So what you can do, I'll be providing this one. This is which will be sent. I'm not sure it will be sent to all. Depends on the organizers, where you can get to download the files that were used in this lecture. Okay, so SYNSM Gamma files. So I gave these are the main two folders that is needed for one particular project. Okay, so the include files and the model files. So the model files contains your codes. Okay, and then the the include files are additional files like the shape files, okay, or the figures, okay, that are being imported into the Gamma environment. So this is where I have placed the buildings, okay. So these are the shape files, okay, and in order for you to generate a particular shape file, okay, you can use, let me share QGIS, right? So I'm still new for QGIS. This is an open source. So for the QGIS, what you need to do is to what you call extract the shape files for buildings and the roads. Okay, so if you open QGIS, it's heavy. It's open source, meaning free. Okay, you can run it in Windows and in Linux. And once you are able to run it in Linux, automatically it will be able to run in Mac. Okay, as I've mentioned maybe in the previous talks, where Mac is Linux based or Unix based. Okay, so if you are familiar with ArcGIS, then better, because you can what you call this, have libraries, okay, and access to what you call these maps that are sometimes not shared. So for QGIS, you will need the OpenStreetMap option, where when you click OpenStreetMap, then you can now look at a particular, so we see here, it's quite heavy. It's trying to download and access. For ArcGIS, I think there's an offline, you cannot run ArcGIS offline on a Mac. You can run it as a client, but it's running on the web, which means you're remotely running it. Okay, so but you still have to get a license for that one. Okay, so here you just have to choose what particular region, maybe a country that you would like to get hold of. Okay, so in this particular, I think, example I did was to zoom in and get buildings and roads for the city of Baguio. Okay, and why city of Baguio? Again, it's some sort of a place where I stay. At the same time, if you have people working on a particular disease located in Baguio, then it is also easier to have data, because those information or that data makes your simulation closer to reality. Okay, again, the data that we have to get hold of are available. Okay, so again, you have there's Baguio here. So you can extract, yeah, I think here, yeah. So yan, we will get to have what, in the center, you will see now that here, this is Burnham, and I will try to extract this portion, okay, where I need to create or get the vector for what you call this, the roadmaps and the buildings. Okay, so you just type buildings, okay, and then you can have buildings here, and then you will have either the canvas or the whole. Okay, so I will just look at a canvas extent, meaning the current screen that I am looking at. Okay, so I have I think center at Burnham. Okay, and I will just run query, and it will try to download the shapefile for that particular canvas or that extent of my window. Okay, and if you will see QGIS and ArcGIS requires a stronger or more powerful computer. Okay. Otherwise, you might try to throw your computer when you try to run these types of packages. Okay, so that's it. It took me around 5 or 10 seconds to build the buildings. Okay, and if you get to have this one, okay, so you will see that you have the buildings marked in here. Okay, and then you can also extract what do you call this, roads or routes. Anyway, so in this particular example, I tried to capture the city of Baguio, but when I ran it with this kind of buildings, took me some time to really analyze, okay, and see the results. Okay, so what I did here is for demo purposes, I tried to clean the shapefile for the city of Baguio, maybe just a portion only. Okay, and also the roads. Okay, so for the roads, you can extract it and then clean it also, because in the construction of the roads, it is important that you create what you call segments, meaning in terms of network, okay, and then the path that it has to take, okay. Then if you have one particular circle which is only one road, then possibly that can be what it will just move around that path. Okay, so there's no choice of getting to the next corner or a corner of the road. So it has to be done in such a way that you have an initial vertex, okay, an end vertex to denote that one particular segment. Okay, so that is, I think, what made me also curious when I saw the group of, just to give credit on the LiDAR group, where some of the students in ComSci were really trying to, what you call this, clean up data that are taken from the map. Okay, why? Again, sometimes these figures, okay, does not necessarily give you what an exact realistic information. Okay, like for example, sometimes if you have trees where it can be that tree is just maybe a point or a circle, might be might be detected as a building. Okay, or on the other way, where you have a tree or a building under the tree, then that building will not be identified. Okay, so that's part of QGIS or ArcGIS. Okay, just extract it, and once we have done that, okay, we will now look at the shape files of our project. Okay, so once you have that, if you look at this, let me close this one. Okay, these are the shape files. Okay, I have extracted. I tried to clean some of them just to make a more interesting simulation, and movements will easily be seen. Okay, just to check if it's working correctly. Okay, again, when you write to see some simulation or codes, it is always nice to start with what you call the basic, meaning a simple case, to make sure that the code is running correctly or as expected. Okay, so I always advise them to first start on a small scale, because we want to check if our implementation is correctly being followed or done by the machine. Okay, meaning as much as possible, when we try to do things, check it if possible manually. If it's being done, then make it in a large scale. Okay, because sometimes we tend to just run it and okay, it's running, but we don't see the details behind if it's running correctly. We just see that, okay, it's running, but some errors or some logical errors are not being observed. Okay. So once you run, what you can do is here just to make sure that your codes, okay, the shared codes that I will be providing, okay, will be able to run is these are the models. So there are 2, 4, 6, okay, sample codes, okay, that you will upload or rather copy into your project, okay, and these are the shape files of the buildings. Okay, so what you can do here, so this happens to be with 0. What you can do now is just create a new project. Okay, so let's just try to simulate. So create project name. Maybe we'll just call it JTest1. Okay, and create a model file. So just to make sure that you're able to create it and link to all the libraries in the Gamma platform. Okay, so it will ask you what a new model Gamma. So author. So it will see that JC Adao is the owner of this computer I'm using. So let me just shift this one. So I'm not using my own machine because my machine is slower compared to this machine. Okay. So here, just click finish, okay? And you will now see that the new model is created, okay? So you now have one model and it creates your first blank code in here, okay? Since you will have different codes, what you can do is either copy the text file here or what we can do is copy all the models inside model here and then the include. So you will see include doesn't contain anything here. Okay, so what we can do is just copy if you have your files later on, then you just have to drag. I think that's to be shared. So let me check. Yeah, I think this is the files that you need. Okay, so for the buildings, maybe you can use only particular files. Okay, you don't have to copy all your shape files in the same folder again. Okay, or you can make a link. So maybe let's say I will just copy. Okay, so just to illustrate here, I will just copy and drag it to JTest, right? So, see, that's the problem. Hang na siya. So, this is now the problem that I'm telling you sometimes. Okay, let's try to, let me check. Let me just, wait. Okay. See, the gamma. I will first make a force quit. Okay, so I will rerun it. So, okay. So the same, let me just go back. Just try, I dragged it in a separate folder. Hopefully don't crash on me. Okay. Okay. So one project, as we have mentioned, so you have this, okay. So what we can do is, as I've mentioned, is create a Gamma project. Let me check this. Okay, finish. Okay, so project name, okay. J-test. Let me just finish. Okay, so yan yung J-test na ginawa ko kanina, nung una pa. So model, I'll stick with this one. Okay, and then finish. Okay. So the same, I think you will have, as you can see, have only one model. Okay. For this particular experiment, you get this one. Okay, so let me just repeat. So you will see the actual things that can be done here. Let me repeat the process. Oops. Okay, and then these are the include files for JTest2. Okay, and drag it to include copy files. Okay, and you will now see that these are in here, and then the models created, there's only one. Okay, since I will be sharing this gamma files, the models, let me just drag again. Wait, am I right? Yeah, the models I think is correct. Okay. This is my problem. This is not my machine. Okay, select what? Sorry. Okay, so models. Drag. Okay, so I have now those files. Okay, so this is the same files I have here. Now, once you have that, then we're using JC2. Okay, so I can now click on this and then the models. Okay, so if we will now start with the simple model. I call it SI model 1. Okay, so as we have mentioned earlier, there are three main parts. Okay, for the code. Okay, the model, we call it SII model, which was adapted by the code of Lunaris Flu, okay, which was constructed by Thailander. Okay, so here, as you can see, this is where you have the section, the world agent, okay, and for a particular command, as you hover on that particular command, it gives you the information. It's like your help file, okay, and in the global, this is where I define the population size. Initially, I start with 20. Okay, and since we're modeling an SI model, so we are now looking at a population with two compartments and susceptible and infected. And we first start with what? Putting those humans in a rectangular space. Okay. And they will be randomly located at any point on that rectangular space. Okay, and initially we have 20. Okay, we can just change this one, and then you have one infected person among the 20. Okay, just like in the usual deterministic model where we use differential equations. Okay, except that the transition from one compartment to the other is defined by that rate, which is your ds over dt. Okay, here it will be based on certain conditions. Okay. Now, since you are trying to assume a well-mixed population, then we will consider agents like the humans, which will be located in the flat region that will just randomly walk around. Okay, so this is where we define the step, okay, meaning the movement of that particular agent is each step will be 5 minutes, okay? So it's like per transition. And then the geometry, as I've mentioned, is a square. Okay, later on we will be extracting a realistic place where in that case is the map of a person in Baguio. Okay, in it you try to create humans. Okay, so these are the species and then the number of humans. Okay, and then see if it is part again of the initial population. Okay, and then we will check if that particular person is infected or not. Okay. Okay, and later on we will use some transitions, and once they interact, okay, and the interaction will be based in terms of its physical location. And if you have a person located close to another one, then that's the time it has to check if it will get infected or not. Okay, so the infection, meaning the transmission, is given by certain probability. Okay, just like in the previous deterministic case, wherein a portion will either get infected or not, depends on the transmittability that you have defined. Okay, except that here it's trying to move at random. Okay, meaning unlike in what you call this, in the previous case where you have a well mixed and in a particular time step, you make sure that they interact, okay, with the whole population. Okay, so species, okay, the skills, meaning it's moving, okay, and then this is the speed, this is the normal speed of a person. So if you try to walk if you start walking, okay, this is defined as around 2 to 5 kilometers per hour. So your rate when you walk, this is just normal, depends maybe on the person. So I just define a range, okay, and then initially you have this condition. So the condition for this is a Boolean, okay, and it initially is false. Okay, so the movement wander means just trying to move around at random. Okay, later on we'll try to change the movement where the movement will just follow a particular path that you need to define. So it is now based on the geometry. Okay, and then as you will see is for this command if it gets infected or not. Okay, so this is where you get the interaction. Okay, and if it is within 1.5 meters, so you can define this just like to be more realistic. If a person is within 1.5 meters, then it gets to have a probability of 0.5. Okay, so this is the flip wherein it's like tossing a coin, okay, or running a probability, a random number from 0 to 1. And if it's 0.5, it will either get infected or not. Okay, so you can have it less or more. Okay, so if in case that you have some conditions like you impose, if you impose physical distancing or rather face mask, then most probably the probability will be smaller. Okay, so this is where you now define certain conditions for the transmission to be either increased or decreased. Okay, so it's just like the chances that this person gets infected is 50%. So it's like flip the coin. And if it's within 0 to 5 or 0.5, then it makes that particular person infected. Okay. and it's done for all. So all of them are moving at random. Okay, so depends on the randomness, wherein some will not be moving. Maybe it depends on these movements. Okay, so aspect circle, meaning it's like trying to visualize the agent, okay, in the map. So just like drawing a circle of this size, okay, and we will now see that either that circle is true, okay, or false. So it's either red or green, okay. And the last part is the experiment. So you see, you have the global, the species, and the experiment. So this is where we try to display those agents. So you either use a map, okay, which is constructed using the circle. Okay? And then later on, we will try to draw a display that represents the time series, as we have seen in the deterministic case. Okay, so this is a simple problem or simple code to start with, as I mentioned, so like constructing an SI model and then simple interactions. Okay, and from there you build other conditions. Okay, so for now we just consider this to see that you have the three main parts of the code. Okay, so if I run the experiment, then what do we expect? It will just display the species of humans, which are denoted by circles. Okay, and initially you have 20 circles with one infected person. Okay. So if I run, these are the number of humans, okay, that are randomly placed in the section of 200 square meters. Okay. Okay, and then if you try to run the code, then you will see that they're just moving around, and maybe you will say, why are these two not moving? Okay. Again, maybe what do you call this? It's trying to move at random, and maybe that person is not moving or selected not to move. Okay, or went back to its current movement. So you will see now that again, at some point, you have the whole population being infected, okay, where the conditions you made for the movements are within 1.5, and then a probability of 0.5. Okay, so that's the simple SI model. Okay, and then we try to build and create a new one. Okay, where here we will now make use of a chart. The chart is where we try to define the time series, the number of infected at any given time. So we try to account for the number in the simulations of agents. Okay, so this is how you monitor it. Okay, and we set some conditions to end the simulation. You will see previously that it's still running, it's still moving because there's no terminating condition for the experiment. Okay, so here we will now introduce a terminating condition where we try to check the end of simulation, which is the infected ratio, meaning the population, the ratio of the number, the total population and the number of infected is equal to 1. Okay, so initially you have an infected person, and it will increase once you get to have the whole population infected. Then we stop the simulation. Okay, so we pause and have this one. So the same, except that what is being integrated into the code is accounting for the number of infected and the number of susceptibles. Okay, so here is integer number of I, number of S. Okay, and just like in the simple GeoGebra approach, we have n minus I as S here. Okay, and it will just update, okay, as you go with the simulation. Okay, the same thing, create humans, okay, and it will check if that particular human is infected or not. Okay, and then the movement still is wandering. Okay, so the reflex is to wander. Okay, so what are the different commands for this one? You can change it later where we will move, depends on the target of the movement. Okay, so there's nothing changed except that, as I mentioned, you account the number of infected and susceptibles. Okay, same thing, gets to infect within a certain distance, 1.5. Okay, and I made the circle smaller here if you want. The previous one is larger, just to visualize. Okay, so circle means that one. Okay, and then the same except for the display. Okay, so the display, you have the map and the display chart. Okay, so it will now try to account the number of susceptibles and the number of infected. Okay, now what is different here is, again, you will just be dealing with the number as an integer, unlike in the continuous case. Okay, so it's like looking here at a discretized form. The continuous case that we did in GeoGebra, at a particular time, you get to have a population which is in terms of fraction. Okay, so the number of infected is some real number. So it's not like what it's having 1.5, 1.3 appearing, okay, as an infected number of humans. Here, we will get to see the simulation will give me an integer value. Okay, so either that person is infected or not, depends on the condition it has to go through. Okay, so that is just the addition to that particular code. Okay, so we started with the simple one and then added that chart. Okay, where it takes into account the number of infected in susceptibles. Okay, so you will have two windows here. Okay, so you will have the map and the chart. Okay, so for the map, again, you have randomly chosen 20, and we have two initially infected humans. Okay. Okay, so the chart gives you the initial population, 18, and 2 infected. So we use the red, okay, as infected and green as susceptibles. So if I run this, it will terminate once we get to have the population totally, the whole population infected. Okay. Okay, so what do you notice? Okay, I think wala nang na-infect. Let's see. Okay, the randomness are still moving except the circles. Okay. Yeah. So let's see the code. Still the same. 2 shape 160. Okay, maybe let's have this one. Maintain it 200. And random 3 circle. Okay, so 1 point. Number of infected, minimum max. Okay, yeah, 10 cycles. Okay, so it's the same. Just make it bigger. Let's see this one. Okay. So we'll now see that the chart, okay, initially starts with this, okay, and you now see a graph which is discretized, meaning the population is in terms of an integer. So it's either, in this particular case, I think 16, this is 18, okay, or 9, yeah, 18, okay. So it will keep on running as long as the number of, what you call this, susceptibles still, or the ratio is not yet equal to 1. Okay, so it will just keep on moving. Hopefully it stops once, luckily, all those humans get to be infected. Okay, so may dalawa pa rin. Okay. Okay, so let's stop that one. Okay, next is the same thing, like I will now try to add the chart, meaning the GIS data. So this is where, what do? We try to, so if you look at the simulations, it gives you an idea where I have a square region, all the humans are moving randomly on that square region, and then just to get an idea how to use the maps, okay, I will input the maps, overlay the map on the square region. Okay, so it will just try to move around. It's like stepping on the map. Anywhere it can just move any place on the map. Okay, so the same conditions, let's make it 100 to, and then where the shapefile now here, okay, is removed, and we will now put the road shapefile in the building shapefiles. Okay, so instead of geometry shape, where the shape is the square, okay, I will now look at the shape files for highways and buildings. But the movement is still the same. It's like, just as I've mentioned, putting in the map on top of the square region, okay? And the restrictions or the movement doesn't make any, what you call this, any idea on where it will try to move to, okay? So just like in the previous two simulations, what we did is just to move and wander, okay? And it will just move around, okay? And the same conditions, okay, I just used 2.5. Realistic, ano ba 2.5? Taba na masyado. That's why, because just to visualize it, I want to see it moving around, okay? And here, you now have what you call the shape file, okay, which is being used, okay? And for the roads, I use a black color, and then for the buildings, just to give you a pink one, okay? So what happens is, like, if you have to, if you look at the buildings, that's build highways, okay? You can click on highways and it gives you the expected highways one, okay? So this is the highways one. This is just the extracted vector in the QGIS package, okay? Okay, so let me go back to 3, and then when I run, as we have mentioned, just put the map on top, okay? That's the map, and then these are the buildings, and these are the agents. So randomly located. It doesn't have to identify if that particular circle is placed on the building or not. Okay, so that's the first thing that we need to do. It's just like, okay, I now have the movements being done on a shapefile. So in order for us to see how we integrate the shapefiles into the code, okay? So it will just be what, trying to step on any point on the ground where the map is over or where the map of the roads and buildings are placed. Okay. Okay, so the chart is the same except that again we just integrated what we call the shapefile instead of the geometry of the square with black color or plain color. Sorry, white color. It will now be made of painting. So the floor is painted by roads and buildings. Okay, and let's see if it works. So that's how we would do our codes here. So you are now able to see that they're moving. Okay, and you are able to integrate the maps. Okay, so the same expression here. Okay, so again, this is the population, and you see that interaction, and will just move around. Okay, that is why if you don't isolate that particular person, then it will just keep moving in a building and tries to infect all the people inside the building. Okay, so very important why if you get to have the symptoms, usually they isolate you or put you in quarantine. Okay, so you will not be able to infect other people. Okay. So that's the purpose why later on why people who are tested positive automatically are quarantined so that they will not move around and infect other people. Okay, so that's where we integrate what? The chart. Okay, and the last one will just be how do we restrict the movements, and later on you can have it move in such a way that you will just restrict it on a particular section of the map, or it will be governed by the path and the targets that they need to go to. Okay, so we will now integrate what you call the fourth SI model would now be trying to integrate the data of the road, okay, and the graph for the movement. Okay, so it will now be moving, but the movement, okay, is within the building, okay, or within the road, okay, and then it will just be located any point on the building. So it's just like I have a target, and the target of that person will be a particular building, and I will move to that building if I have a path, okay, which is denoted by the graph. Okay, so that's where we have to clean sometimes the graph, as I've mentioned, when I did try to look at just extracting the shape files. Some of the shape files is just a plain connection to one point to the end, meaning it does not consider that a particular road connecting it to the main highway is the end. Okay, so because each segment is very important, meaning when I have a road, one road, if let's say the road from here to from my place to UP is just one, then that's only one road. Therefore, if I have a target and then I will move through that road, then my only path is from the initial point to the what do you call this, to the end point, which is automatically what do you call this, UP Baguio. So I will not consider other points where I have an intersection. So it has to be identified in such a way that on a particular place where I can either choose Okay, so I have a choice if I have to move, okay, to that particular node. So you look at a particular node on a segment. Okay, so you try to divide the whole segment into sub-segments. Okay, so that's the use of the path, because when you run the code of Gamma as they have implemented is to use the network, and it considers the graph where you have an initial node and the end node is a way of detecting its target. Okay, and then from that target it has to choose if it has to branch to another what do you call this, another path, because it has to locate the shortest path to a particular point on the graph. Okay, so again, what's happening here is a particular segment can be considered as what do you call this, one path. Okay, so there's no choice or there's no way that it has to deviate from that path unless there's a point within that path that it has to check if it will be able to get to the next node in the shortest way. Okay, so here I think I use buildings tree. Sorry, I'll use buildings first. Okay, so buildings tree is where I just try to choose particular buildings that I can move to, meaning my targets. Okay, so what do you notice? There's the use of what you call again the graph uses a road graph. Okay, and then shape files will be the buildings. Okay, but the movement will now be through the graph. Okay, so if you look at the target, so I will now the reflex wonder of the previous code. Okay, will now look at a target, meaning I will check and randomly check if my target will be this building or that building or building 1 or building 2. Okay, and it will now have any location in one of the buildings, meaning you have a list of buildings. That's why the number of buildings are labeled. Okay, and then the road is also labeled. Okay, in terms of segments already. Okay, so the movement, as you can see, will just be along the road going to a particular target. So the target here is again making some random in its target. Later, you can maybe make it more interesting where your target will just be limited to particular buildings. Okay, so that's where you impose like conditions when you have a lockdown, then you can try to close that particular road. Okay, so meaning there's no connection where I can go to that particular path. Okay, okay, so that's the what do you call this? That's where I will have the road, the segment not connected to that particular path. So we will see, illustrate this. So here, when I run it, it's the same. What I'm trying to say here is, again, we're trying to move around, except that it will move through this target along the path. Okay, and I still have to draw the buildings, draw the roads. Okay, and then we'll have to display the chart for to account for the number of susceptibles and infected. Okay, so and simulation when we have this ratio being equal to 1. Okay. So you will now see that I have the same chart. Okay, for the map, it's the same one. Okay, so this is the extracted shape file from street map. Okay, I just had to look at this one. And what is different here is the road shapefiles. Okay. So you will now see that this point here is not connected. Okay. Meaning it's just not connected here. Okay. And I had to divide some of the segments. Okay. So if I have this path going here as one path, then the tendency will just move, and the target will just be this one. So if my target will be this, then it has to go through here and then goes to this point. Okay. Okay, so if you zoom in, these are the humans or agents randomly placed, and you will now see that the placement are all inside the buildings. Okay, so it considers the polygons where I will put a particular agent in a particular polygon, which is represented by the buildings. Okay, and then it will move through these ones. Okay, so if you zoom in, you will see now that the humans are trying to move, okay, only through those paths. Okay, and then targets, as we have mentioned, its target will be, let's say, this building. That's why you will see that some are appearing in there. And then within that particular region, it will check if its location will be get infected or not. Okay. So what is seen here is like, again, there's no one moving in this point, okay, or on this road, because I to disconnect this one. So this is just a disconnected point, okay. So this is where you will now see that, suppose I put a lockdown, this region, okay, will not be infected unless there are some movements in here, okay. Okay, so the display chart is the same. We'll just simulate and we'll try to move on those particular targets. So you can try to monitor the movements of the agents. Okay. Okay, let me just, so this is to just illustrate why I think I choose buildings. I try to clean the buildings, okay, and then try to identify only particular targets, meaning the buildings are those points that they will be able to move, okay. So I think buildings 3. Yeah, okay. So the same. So if these are the buildings only that I choose to be targets, okay, then it's the same as trying to see how they will move, and they will just be moving along those roads, okay, and as you will see, it gets to get infected this part, and this one is, as we have seen earlier, I can have this as some sort of a road which is in lockdown, okay, or I tried to isolate this building, okay, and you will see how maybe how long it will be able to infect the whole place, okay. So that's where we get to have the simulations. So we get the discretized form for the SI model, and here are some visual that restricts the movements and affects the population of each compartment. Okay, so this is where we can now try to impose additional conditions, like having to, what you call this, lock down a particular barangay, okay, or have particular buildings only as targets, meaning they are only allowed to move to those buildings, okay, and give us an idea on what happens to the dynamics or to the particular city in a particular period. Later or in the next revisions, you can consider movements only on what? On days. So you can now use the time of the day, wherein you have a 24-hour clock, and they are only allowed to move from 8 to 5. Okay. And the rest, there's no movement at nighttime. Okay. And what we can do is you can allow certain movements at nighttime on a particular group of agents only. Okay. So you will see that here I can browse the agents and see the characteristic of a particular agent, okay, and its particular destination, meaning the target, okay, the heading, the destination is, these are based on the shape file, which is in terms of its destination. If you look at the GIS, okay, geographical information of this one, this is the location of this particular person, okay? So it gives you an idea if it's infected or not, okay, and what particular road it is located, okay? So that's where I labeled random human 0, okay? And here we can later on impose stricter conditions where maybe humans, you can identify a certain group of humans as frontliners, so they are allowed to move maybe on a particular road or a particular building. Okay, so you can limit the movements of these humans if you identify them. Okay, and see the dynamics on or the visual on the dynamics of the disease on a particular part of Baguio. Okay, so you expect that this will stabilize. It will not stop because again, you have seen that in the map. I have this location. Okay, so if you look at this one, I think this is a particular building that I have identified. Okay. Okay, so let's stop there. Maybe just to give you extension. Let's say I gave and then we started with SI. You can now start with SEIR, right? So in the SEIR, this is the backup. Okay. Again, we did try to define it in terms of the 4 compartments, and then I just have to comment out the movements yet. Okay, so start with the first simple one. Okay, just like in an SI where it will be represented by circles moving around on a particular region, and then but it has to go through some stages. Okay, so it can be either susceptible, exposed, infected, or recovered. So exposed, this will take some time for it to move to an infected class. Okay, so again, it will just move around. Okay, and I will label susceptibles, I think, as green, and then infected as red. Okay, and then red, and then green, then I think green, blue, or orange. Yeah, orange, yellow. Okay, so green, green, orange, red, blue. Okay, so green, and then orange, and then red, and then blue. Okay, so it will just take into account again the chart and then the movements. So if we run the simulations, we initially start with 2, 4, 6 susceptibles. Okay, and then interacts within a particular space. And then if it gets into contact with another person which is infected, there's a flip, okay? And once it gets to be infected, luckily it gets infected, then it moves to an exposed class. And then the exposed class will run, okay? It will not yet infect other people, but for some time, so there's a duration, that's like your latent period, right? Wherein you just get to be exposed, and after a few days, depends on the time that we define, gets to infect other people, okay? So if you run, then you will see now that you get this one, okay? So when you look at the chart, okay, then you will see now that this is the infected population, okay, after some time defined by this, okay. Okay, so you will see that since due to randomness, it will just move around, and then it gets into contact, so you get this one, okay. Unlike in the explicit in the deterministic form, that you will expect that it will just go down or stabilize, okay. Okay, so next is we can put again the building, just like what we did in 3, and then put the movement, okay, along the path. Okay, so just like as we mentioned earlier, we can tag a particular region in the path or in the population. Okay, so I think that's it. I need to go back to this one. Okay, so again, visualize what we have seen here. So in that particular case, we can look up a particular disease that occurs in the city of Baguio. Okay, and let me end that. Share with you that again, art is a lie that helps us to discover the truth. So from Picasso, I would really agree with this. And thank you for your attention. And hopefully we, or some of you, will be encouraged to play around with that particular package. Okay. And again, thank you for listening. If you have questions, maybe you may ask them now. Okay.
Hello, sir.
Yes.
Sir, there is a question here po. May question ako regarding sa movement ng mga agents which are humans po. Pwede kayang maglagay ng predetermined schedule yung movement nila? Kunwari po, kapag magkakaroon ng subset yung human based on their occupation, for example, mga teachers po, pwede kayang yung movement ng mga teachers is merong present na movement pattern?
Come again, mayroong?
Kung meron po bang, kung pwede po kayang yung movement ng mga teachers is merong preset na movement pattern, sir. Parang maglalagay po ng predetermined na schedule po, sir, yung movement po nila.
Yeah, I think that's an interesting question, wherein just like wherein I move around, so I get a particular target, and then you are saying that that particular time, it will try to reset its initial attributes or its current attributes. Parang ganun siguro yung mini-mention niya, which can be done. It's like you are trying to reset that particular agent to a particular what you call this attribute, depending on the condition. Okay? Just like in the time wherein in a particular time you can set it such a way that from 8 to 12, because it's looking at the time, okay, then it will not move on that period. So I think that's the same idea that is being raised. I hope I answered the question. Yes, it can be done. but it again, yeah, you first play around with the what you call this, the movements.
Thank you so much, sir. Other questions po?
Any other questions? Okay. So the more or less, I would say that when we try to study a new language, okay, it's always nice to start with what you call these simple movements, simple simple models, so as to see the what you call this, the relevance of putting in the other interesting dynamics you want to incorporate. Okay.
Sir, siguro last question na lang po. Can you combine ABM to other types of modeling po?
Yeah, I think when you say other types of modeling, you can integrate the movement wherein you have a formula like putting in some equations into the restrictions or movements that you have defined here. Okay, so you can try to combine it in such a way that you have some sort of deterministic conditions on some of the movements of the agents. I think that's the idea. I hope that answers your question when you say combine it. Okay.
Sir, thank you very much po. And I guess that's it po. Before we end this session, pwede po ba nating bigyan ng online or virtual applause po ang ating speaker? So thank you so much, Sir Joel, for sharing very interactive po and innovative po na discussion for today. And before we end our session, pwede po tayong mag-open, magkakaroon po tayo ng photo opportunity together with Sir Joel. Pwede po nating start po sana itong ating camera. Ayan. Okay. So at the count of 3, ayan, hintayin lang po natin na mag-open ang cameras.
Okay.
At the count of 3, let's strike a pose po. So 1, 2, 3. Smile. Then next page. 1, 2, 3. Smile. And thank you very much po. Okay.
Thank you.
And hope to see you. Our next, this is our last session po. Meron po tayong plenary speaker this coming 3 o'clock. Ayan, habol po tayo sa ating 3 o'clock PM na session which will be delivered. Ang plenary 2 will be delivered by Dr. Juancho Collera. So, yung links po ay nasa email po ninyo. Kindly register po there and bibigyan po ulit kayo ng email na nandun po yung meeting ID and password. Thank you so much po for joining. For the evaluation,
Bye.
thank you. For evaluation po, nasa ating chat box. So, please do refer on that one. Thank you so much and thank you for joining us.
Pero
Thank you.
pa lang, nag-play na lang muna ng video.
Salamat. Ingat sa lahat. Stay safe.
Thank you, sir.
UP Baguio is built on a pine-clad hill in the heart of Baguio City. For 50 years now, since its establishment in 1961, UP in Baguio has worked at serving as the lead institution in the delivery of tertiary education in Northern Luzon, sustaining its efforts at modernization, the strengthening of curricular programs, and the active generation of knowledge through research. UP Baguio is also a green campus in the truest sense of the word, with all sectors committed to the preservation and planting of various trees and plants within and around the campus. It is indeed as the UP in the north that UP Baguio has quite proudly evolved into, carving out a niche in Cordillera studies developed over the past decades. The Department of Mathematics and Computer Science, or DMCS, was first established as the discipline of the Division of Natural Sciences and Mathematics, or DNSM, in 1961. The DNSM was then reorganized as the College of Science in 2002, consisting of 3 departments, namely Biology, Physical Sciences, and Mathematics and Computer Science, and 1 Human Kinetics program. It is the mission of the department to adhere to the highest standards of excellence in all aspects of teaching,